Alright, let's go over homework 3.2, number 10. Alright, so we're looking for the equations of the tangent line to this given curve right here. And also they have to be parallel to this given line. Alright, so first I'm going to rewrite this equation right here so that we can see its slope. So I'm going to solve for y. So I'm going to first subtract x from both sides. You can get negative 2y is equal to negative x plus 5. Right? Then we can just divide through by. So maybe I'll do that here. Divide through by negative 2. Right? So that will give us y is equal to, right, negative x divided by negative 2 would be 1/2 x, and 5 divided by 2 is negative 5/2, right? But all we care about is the slope. You can see that slope is sitting right here, which is at 1/2. So both of these tangent lines have to have a slope 1/2. So we already know the slope is 1/2 here, and for this one as well. Right? Then we have to find the point of tangency where the slope is exactly equal to 1/2. Right? So if you want to look at the derivative of the given curve, so we need to take the derivative of this. So let's take the derivative of that. So y prime is equal to, right? So using a quotient rule, we can take the derivative. X plus 1 squared, right? Then take the derivative of the top, which is 1, times the bottom, which is x plus 1, minus, and top is x minus 1, times the derivative of the bottom, which is just 1, right? So you can see that you can simplify it as, let's see, x minus x, so x minus x cancel out, and you have 1 minus negative 1, so 1 plus 1, so it's 2 on top, right? Then on the bottom is quantity x plus 1 squared. All right, so that's the derivative, and since the slope has to be 1/2, so the derivative has to be equal to 1/2. So we're going to set that equal to 1/2, right? Then what you can get is, let's see, we can just multiply both sides by x plus 1 squared. You will get, let's see, 2 is equal to x plus 1 squared over 2, right? Then we can multiply both sides by 2 to get the 4 is equal to x plus 1 squared, right? Then we can just take the square root of both sides. Then you can see that the square root of 4 is 2, but we have to worry about the plus or minus 2. Then you have x plus 1, right? So which means that we know that there are two x values when x equals, right, when you have positive 2, we subtract 1 from that, so it's going to be positive 1 is one of them, all right? Then when it's negative 2, subtract 1, so it's going to give you negative 3. All right, so those are the x1 values. So for this one, I'll use 1, so 1. And for this one, I'll use negative 3, right? Then we can find the corresponding y value. So we plug 1 into the original function. You can see that the 1 minus 1, 0. So you know that the corresponding y value is 0 for that guy, right? When x1 is negative 3, then if you plug in here, so you have a negative 3 minus 1, so it's negative 4. Maybe I should do it here. Negative 3, right, minus 1 over, right, negative 3 plus 1, right? So that's going to give you negative 3 comma, right, negative 4 divided by -2. So it's +2. All right. So we can get an equation by point slope form. We have y minus y1, which is 0, is equal to 1/2 time quantity x minus x1, which is 1 for that. All right, so you can see that the equation is, if you clean it up, y is equal to 1/2 x minus 1/2 by distributing 1/2 to both terms. All right. The second one is going to be, again, using the point slope form, y minus y1. y1 turns out to be +2 is equal to 1/2 quantity x minus -3. So it's going to be +3. All right. So if you multiply that out, you get 1/2 x plus 3/2. All right. Then all we have to do is add 2 to both sides. So you have, let's see, you're going to get y is equal to, by adding 2 to both sides. So you're going to have 1/2 x plus 3/2 plus 2. 2 is 4 halves. So it's going to be 3 plus 4, 7/2. All right. So you can see that tangent line 1 is 1/2 x minus 1/2, right? And tangent line number 2 would be 1/2 x plus 7/2, right? So this has a larger y-intercept. That should be all right. All right, that's it. I hope that this was clear.